Whispers in the morning.
Okay, welcome to the Easy World of Science. Today, we'll take a look at this mathematics 2021 WAEC mathematics objective questions. We'll start from number 1. You see the question number 1 there on the screen, and it says correct 0.00798516 to 3 significant figures. When we talk about significant figures, we are talking about figures that is up to 1. So 0 is an insignificant figure. So the number that we are asked to correct is 0.00798516. So here is 0, is insignificant, this is 0, this is 0. So we started from here. This is the only number that is significant first, then 2, 3. Then the number next to it is up to half of 10, which is 5. So you take this as 9. So the correct thing should be 0.0799, which is option C. Then next question, question number 2, as you can see on the screen, says simplify 11 base 2 square. 11 square base 2, that's 11, in base 2 and square. As we all know that a number squared means that number times that number again. So we go with 11 times 11 first. So it's going to be 1 times 1 is 1, 1 times 1 is 1, then this one, 1 times 1, 1, then 1 times 1 is 1. Then you sum it up. Remember, you're going to sum in base 2. Just like some of you don't know. Sometimes you don't know why 10 plus 10 in base 10. Why is it 20? How many 10s are here? 1, 2, remainder 0. That's why it's 20. So here, we are going to add in the packets of 2. So what we have here is only 1 remaining. It's not up to 2, so you write it. Then 1 plus 1 is still 1. There is 1 packet of 2 there, remainder 0. Therefore, it's going to be 0. You carry that 1 plus this 1 again. It becomes 2 again, which is 1, 0. That is 0 and 1. So the answer is 1, 0, 0, 1, which is option A. Okay? Then the next question, question number 3, is to solve 2 raised to the power 2x plus 1 equal to 32. We will be using a lot of indices here. We will make them, we'll develop it into common base. We make sure that they all have the same base, meaning the 2 is the base, so we convert this to 2. How many times will you raise 32? What number will you raise 2 to get 32? So it will be now 2 raised to the power square root of 2x plus 1 equal to 2 raised to the power 5 is automatically 32. So we have developed a common base, a cancel out, so that we are left with 2x plus 1 equal to 5. Then, to remove the square root, we square both sides, of course, equal to 5. Therefore, this should be square and square. Then square cancel square. We are left with 2x plus 1 equal to 25. Then such that 2x mathematically is equal to 25. This will cross here, minus 1. Such that 2x is equal to 24. X alone is equal to 24 divided by 2, which gives us 12. So when we look at the option C is the correct answer, 12. Okay, remember to ask your questions in the comment box. Then, question number 4, as you can see there on the screen, question number 4 says, if log 2 base 10 is regarded as m, then log 3 base 10 is taken as n. Then find log 24 base 10. In this case, we will try to break down 24 to be in terms of multiples of 3 and 2, because that is the number they gave us. Just break this 24 down to be multiples of 3 and 2. So solution in this case is, we are required just to say that log 24 is also log 12 times 2, because 12 times 2 is 24. If you watch it, they did not give us 12, it's still we only have 1, 2. So we have to break this 12 further down, such that, remember that in 12, it says 6 times 2 is also 12 times 2. 6 times 2 times 2 is still 24 base 10. This is still not in the either 3 or 2. So you still break it down further, such that we now have log 3 times 2, which is 6, times 2, which has been there, then times this 2. So in this case, we have broken it down. And if you check how many of the log 3 do we have? 1, then 3 2s. So which means what we have now is, actually we have log, just one of it, then 3, 1, 2, 3, 3 log 2. And they told us that log 2 should be seen as n. So I'm correct there? Yes. Then log 3 should be seen as n. Okay, so remember actually in indices, the multiplication should be plus, of course. Then we have log 3 plus 3 log 2, because we have 1, 2, 3, they are into 3, then there is only one of these. So no need of writing this one now, because it's already there. Normally, the coefficient of x in maths is still 1. So what we have here is that you now convert this to n plus, this 3 is constant. Anywhere you see log 2, replace it with n. So at the end, we have 3n plus, yes, 3m, sorry, 3m, so n plus 3n. If you check the option, I think option A, yeah, have it, 3m plus n, that is the answer. Then the next question, question number 5, says find the fifth term of the sequence 2, 5, 10, 17. The sequence okay. 2, 5, 10, 17. In this type, I wouldn't know the accurate formula, but you use your discretion to check the rates at which it is varying. They are looking for, this is first term, second term, third term, fourth term, then the fifth term should be what? If you check, let's say you say 1 plus 1 will give you this. If you say 2 plus 2, it will give you 5. So it's not in that mood. So let's take, okay, let's take n squared, that's the thing. N squared plus 1. Where this is the first term, second, third, fourth. So if we check if it's rhyming, this is here, n is 1. So 1 square plus 1. 1 square is 1, which will give you 2. Then here, the n is 2. 2 square plus 1 is 5. So it's rhyming. So 2 times 2 is 4 plus 1, which is 5. Then here is 3 squared is 9 plus 1, which is 10. And here, square of 4 is 16 plus 1, which is 17. So the next term should be automatically 5 square plus 1. And 5 square is 25 plus 1, which will give you 26. So, looking at the options, yeah, option D is the correct answer. That is the fifth term. So if you are told to find the sixth term, you can also do it 6 square plus 1, which will give you 37. So that's the sequence. That's the order it is following. Okay, then question number 6, you see that on the screen says, if P is a kind of set, if P brackets have minus 3 less than x, x less than 1, and then Q minus 1 less than x, x less than 3. So it's very simple. You find the members. If minus 3 is less than x, it means that x is greater than minus 3. So the number that is greater than minus 3 in calculation are minus 2, minus 1, and 0. These numbers are automatically greater than minus 3. Then the same x is less than 0, which means is less than 1. Therefore, you cannot add 1 again, because they have told you that x, you see there on the screen that x is less than 1, but more than minus 3. So this is the member of the subset of the set P. Then let's see the members of Q. They say that Q, that x If minus 1 is less than x, it means that x is greater than minus 1. And the only value that x can assume here is automatically 0. And the same x is also less than 3, which means 1 and 2 should come in. So this is the member of Q. Then they asked us P intersection Q, that is the character in P and also in Q. If you check it, minus 2 and 2 is not the same. Take note. Minus 1 and 1 is not the same. So we just have 0 and 0. So P intersection Q is nothing but having a 0 member. Then looking at the option, they gave the option in a very much confusing way. It's not, but yeah. When you look at option A says minus 1 less than x, then less than 1. Check this. The only figure here is 0. 0 is greater than minus 1, but less than 1. So the answer is option A. Okay. Then the next question, question number 7, says factorize 6pq minus 3rs minus 3ps plus 6qr. Okay, in factorization, we have to use a description. When you look at the questions there, you see the members there, you can factor 3 out. Yes, yes, yes. Say factorize, that's question number 7. PQ minus 3RS minus 3PS plus 6QR. Okay, you have to factor 3 out because these things can be multiplied by 3. So if you factor 3 out, 3 brackets, 3 divided by, that's 6 divided by 3 should be 2PQ minus 3 divided by 3 is 1RS. Okay, I have the signs correctly. Then 3 divided by 3 will still be 1. We have PS, then plus 2QR. Okay, then collect like terms. We have PQ, QR, and there are 2 here. 2Q, so this have to go. We have 3 brackets, 2PQ plus 2QR. Then we have minus RS minus PS. Then we have to still factor again, sub-factorization. If you check 2PQ and 2QR, the common thing there is 2Q. 2Q is common, so we can now say 2Q bracket again, P plus R. Yes, make sure that when you expand, you still get back. If you say 2Q times P, it will still give you 2PQ, then 2Q times R, it will still give you 2QR. Then minus, we still factorize this, RSPS, the common thing is S. So we bring factorize S, bracket, minus S times R is minus RS, of course. Then here you have to be careful because minus times minus will give you plus. By so doing, you have changed this sign. So how do you maintain this sign? This is supposed to be plus because minus times plus will give you minus. So this should be P. Then having the common factors here, we have that 3 brackets, you choose one, 2Q minus S bracket P plus R. Remember, P plus R and R plus P is the same. So this should be the correct answer. Let's look at the option. Option A says 3R minus, no, not minus. B says, yeah, B is correct. Only that they brought this one here and this one here. But
Hi, my name is Cheryl.
And I'm Jennifer.
Guess what? There's a channel called Sam Majesty Easy Word Science.
And do you know the best part?
It
makes science so easy. Wow.
It makes science easy, simplified, and very, very fun.
Guess what? Rocket science ain't rocket science anymore.
It's now ABC.
Like if you did science your entire life.
Another thing about Her Majesty Easy World Science channel is that he makes available laboratory equipment and reagents.
Guess the best part, if chemistry has been hard for you, he does tutorials.
And another thing is when you order for these things, they are high quality and they are also cheap and affordable for anybody.
If you want to order, just look at the number below the screen.
And don't forget to subscribe and hit the little notification button down below.
Don't forget to share, of course, obviously, there's love in sharing.
Thank you! We'll see you there.
It's still the same thing. Then question number 8 says, what number should be subtracted from the sum of 2 whole number 1 over 6 and 2 whole number 7 over 12 to give 3 whole number 1 over 4. This is still just a simple summation. Don't fear the number, you still use your normal summation panel. They say, what number should be subtracted from the sum of 2 whole number 1 over 6 and 2 whole number 7 over 12. So your job is to sum up the two numbers first, then subtract it from x or n, which is unknown, and then equate it to the 3 whole number 1 over 4. Simple. Question number 8 is what we are solving now. We have 2 whole number 1 over 6 and 2 whole number. We are going to sum this 7 over 12. First, what we need to do here is, as usual, single fraction, not mixed fraction again. 6 times 2 is 12 plus 1, 13 over 6, plus 12 times 2, 24 plus 7. 24 plus 7 is 31. I guess I'm right, yeah. Over 12. Yeah, then if you have this type of fraction, you take your LCM as usual. The LCM of 6 and 12 is 12. And 6 divided by 12 will give you 2. 2 times 13 will give you 26 plus 12 divided by 12 is 1 times 1 times 31 is 31. So at the end we have 6 1 is 7, 2 this is 5, so 57 over 12. Then they told us that what number must be subtracted from it to give us. So we subtract the number unknown, which means 57 over 12 minus x will give us automatically, according to them, 3 whole number 1 over 4. We still convert it to a single fraction, not a mixed fraction again, which is 57 over 12 minus x is equal to 4 times this is 12 plus 1, still 13 over 4, such that mathematically 57 over 12, this goes here, becomes plus, then this comes here, 13 over 4 equal to x. So we still do our LCM. LCM of 12 and 4 is still 12. 12 divided by 12 is 1. 1 times 57 is 57 minus 12 divided by 4 is 3. 3 times 13. 3 times 13. 39. 39. Okay. 39. So that we have, I think this is 26, right? Yeah. So that we have 57 minus 39. 57 minus 39. Oh, 18, sorry. That should be 18 over 12. We break down, 2 can still go, 9 over 6. Then 3 can still go. If 3 go, it becomes 3 over 2. Yeah, 3 over 2. Let's check our, if you do 3 over 2 there. 1 over 3, 1. Okay, let's convert to, they give answer in mixed fraction, that B or C. Okay, this is equivalent to 1 over 1 over 2 because this is this. So the answer is B. Option B is the correct answer. So the next question says, question number 9, as you can see down on the screen, says, Mensa is 5 years old and Joycey is thrice as old as Mensa. In how many years will Joycey be twice as old as Mensa? Mensa is someone and is 5 years old, and Joycey or Joyce or whichever is thrice as old as Mensa. So at that point, Joyce is 3 times 5, which will give you 15. We can even use normal reasoning here without even much equation. I'll still give you the equation, the mathematical equation of solving, but I think this is a word problem, and some word problems should be reasoned out. Let's assume that this is Mensa, and this is Joyce, this guy is 5, and this guy, or this person is 3 times this person, which means this is 15. So they are now asking us, you know that 5 times 2 is not, they said, in how many years will Joyce be twice as old as Mensa? That is, when will this person's age be actually this person's age times 2? You see that 5 times 2 is not 15, so it's not working. Let's assume in 1 year, in next year, this one will be 6. Next year, this one will be 16. 6 times 2 is not 16, so it can be in the next 1 year. Then in the next 2 years, this one will be 7, and this one will be 17. 7 times 7 is not 17. In the next 3 years, this one will be 8, this one will be 18. 8 times 2, that's twice, it's not 18. In 4 years, this one will be 9, and this one will be 19. 9 times 2 is 18, and it's getting closer. Then 5 years later, this one will be 10, and this one will be 20, and 10 times 20, and 10 times 2 is 20, which means this person's age now, in that case, Joyce's age is equal to Mensa's age times 2. So the answer should be in 5 years. Simple reasoning. In 5 years, which is option C. Yes, in 5 years, the Joyce will be twice as old as Mensa. Or let us now call the year X. It means that if X is the year unknown, it means that 15 plus X is equal to 2 brackets 5 plus X, because this is Joyce's age. So mathematically, we have that 15 plus X should now be equal to 2 times this is 10. Yes, they say this person's age is twice this person. This is Joyce, this is Mensa, so I think I'm correct there. Plus 2x. So what we have, we collect like terms such that x minus 2x is equal to 10 minus 15. Such that minus x is equal to minus 5, such that x is equal to 5 years. So very correct. So that's it. The next question is, they say if 16 times 2 raised to the power x plus 1 equals to 4x times 8 raised to the power 1 minus x, find the value of x. This is your indices. Remember, in indices, plus is minus. Sorry, plus is multiplication, and multiplication is also plus. So we're going to do it. We solved a similar question. We will have to put them in common base and cancel out the bases. So we have to put them in common base. First, 2 raised to the power what will be 16. 2 raised to the power 4 should be 16, because 2 times 2 is 4 times 2, 8 times 2, 16. Then times 2, which is already there, x plus 1 equal to 2 raised to the power 2x times 2 raised to the power 3 is the same thing as 8 bracket 1 minus x. Okay, then cancel out. They are in similar base. What we do now is we are now left with 4, where times now is plus. That is it, plus. When you open the brackets, plus x plus 1 equal to 2x. Multiplication turns to plus. Open the bracket, 3 times 1 is 3 minus 3x. That's 3 times x. So collect like terms. This is 4. So let's shift numbers here and keep x here. This is x minus 2x, then plus 3x equal to the 3 remains here. The 1 comes. This plus 1 is now minus 1. Then this one is minus 4. So we have that x minus x x minus 2x is minus x. Minus x plus 3x will give you 2x equal to 3 minus 1, of course, is 2 minus 2, which will give you minus 2 at the end. I hope the mathematics is correct. So in that case, we have that x alone is now minus 2 divided by 2, such that x is minus 1. Do we have anything like minus 1 in the option? We are solving question. Oh yeah, that's option D. That's the answer. Okay. Then question number 11 says the circumference of a circular track is 9 kilometers. A cyclist rides round it a number of times and stops after covering a distance of 302 kilometers. How far is the cyclist from the starting point? From the starting point, in this question, you should assume that wherever the cyclist starts, the distance is 0. The starting point is 0 distance. And one complete cycle should be 9 kilometers according to this question. And after everything, the total distance covered is 302. So you should ask yourself, how many 9 kilometers are there in 302 kilometers? You do that by dividing 302 by 9. Probably there should be a remainder. Then find the percentage of the 9 kilometers that should be there. Okay? Then, a cyclist moving a circular track of 9 kilometer circumference, so which means one circumference is 9 kilometers, and he covered a total of 302. So for you to know the number of cycles the cyclist has completed, you say 302 divided by 9. 302 divided by 9 is equal to 33.555555. Okay, that's that remainder. 33.55555 to infinity. So approximately we have just minus. So we have 33 complete cycle completed. Then left is 0.56. This is the 1. It's not yet up to 1. And then remember that one complete cycle is equivalent to 9 kilometers. So it's a simple thing. You say if one complete cycle is represented by 9 kilometers, what will 0.56 represent? You cross multiply such that x is equal to 0.56 times 9. Times 9. 5.04, that's approximately 5.04, which is 5 kilometers. That's the distance of the cyclist from the starting point, because he has completed 33 cycles and now started a new cycle, which represents 0.56 of one cycle, and one cycle is 9 kilometers. Mathematically, you do it this way. You find out that the distance from the starting point to where he is in the 34th cycle is 5 kilometers, meaning it remains only 4 kilometers for you to make it 34.
I love you. Thank you for watching.
You are Alpha and Omega.